You're doing 50 kilometers an hour. A kid runs into the road. A cyclist swerves. The light turns amber, and a truck is pulling out from the right. You process all of that in about half a second and make the right call. Now imagine you're a computer. No instincts, no fear, no years of experience, just sensors and maths. How does a machine handle that? And can it actually do it reliably? Here's the real challenge. Driving isn't one hard problem. It's about 15 hard problems happening at the same time. You need to know where everything is. You need to predict what everything is about to do. You need to decide what you should do in response. And you need to do all of that continuously, in real time, while moving at speed. Humans do this almost entirely on autopilot. We barely notice how complex it is until something unexpected happens and our heart rate spikes. For a computer, none of it is automatic. Every single piece has to be engineered, trained, and tested. So how do they actually pull it off? We're going to break it into 4 layers. How the car sees the world, how it understands what it's looking at, how it predicts what's about to happen, and how it decides what to do. All in real time. Let's go. Before the car can decide anything, it needs to know what's around it, and it doesn't rely on just one sense. It uses 3. First, cameras. These work like your eyes. They capture color, texture, and visual detail. Great for reading road signs, spotting traffic lights, recognizing lane markings. Second, LiDAR. This stands for light detection and ranging. It fires out millions of laser pulses per second and measures how long they take to bounce back. The result is a precise 3D map of everything around the car, accurate to within centimeters. Rain, bright sunlight, a black car at night. LiDAR doesn't care. Third, radar. Shorter range than LiDAR, but brilliant at measuring speed. It tells the car exactly how fast that truck ahead is moving. These 3 systems run simultaneously and cross-check each other. If the camera misses something, LiDAR might catch it. If LiDAR struggles in heavy rain, radar still works. The car builds one unified picture of reality from all 3 feeds at once. Seeing isn't the same as understanding. The car now has a map full of objects, but it doesn't know what any of them are. This is where AI comes in. The car runs the sensor data through a neural network, similar to the kind we talked about in episode 2 when we covered computer vision. The network has been trained on millions of examples. What a pedestrian looks like from behind, how a cyclist moves, what a parked car versus a moving car looks like at night. Within milliseconds, every object in the scene gets classified, and crucially, it gets a confidence score. 97% sure that's a pedestrian. 63% sure that's a cyclist. The car knows what it knows and what it's uncertain about. Classification isn't enough either. A pedestrian standing still is very different from a pedestrian about to step off the curb. So the car runs a second model, one that predicts motion. Based on where each object is, how it's moving, and what objects like that typically do, it generates probability clouds. Here are the most likely places this thing will be in the next 1 to 3 seconds. This is similar to how your brain works when you drive. You don't just see the child on the pavement. You register that they're facing the road, they're moving toward it, and you preemptively ease off the accelerator. The car does the same thing, mathematically. Now comes the decision layer. The car has a destination, it has a route, and it has a constantly updated map of everything around it with predictions of where things are going. The decision system runs through thousands of possible actions. Speed up, slow down, steer left by 3 degrees, brake fully, and scores each one. Safety first, then comfort, then efficiency. It picks the highest scoring action, executes it, and immediately starts the entire cycle again. This loop, sense, classify, predict, decide, runs roughly 10 times per second. Not once, not occasionally. 10 times every single second, indefinitely. So where does this leave us? Self-driving technology is genuinely impressive, and also genuinely hard. The sensor fusion, the real-time AI classification, the motion prediction, it all works remarkably well in controlled conditions. The part that's still being figured out is the edge cases, the situations that almost never happen but absolutely will eventually. A mattress falling off a truck, a child in a costume, road markings painted over incorrectly. Human drivers handle these through instinct and improvisation. Teaching that to a machine is a deeply unsolved problem. Full self-driving on every road, in every weather, in every country? That's still a way off. But highway autopilot, assisted parking, collision avoidance. Those are real, they're here, and they've already saved lives. The car doesn't feel fear. It doesn't get tired. It doesn't get distracted. In the situations it handles well. It handles them extraordinarily well. Next week, we're going to look at something that feels almost like magic on the surface, but is actually built on the same foundations as everything we've covered so far. How does an AI look at the words, a cat wearing sunglasses on a beach, and paint you a picture? From nothing, in seconds, that one is going to blow your mind. Subscribe so you don't miss it, and we'll see you in the next one.